This is Don Nelson. I'm editor of the Additive Report, and I'm at FABTECH 2019, specifically at the Wilson Tool booth. I'm with Bryan Rogers, and we're going to talk a little bit about additive manufacturing and tooling for press brakes. About a year ago, you folks rolled out the Bend 3D program. Why don't you explain to us what that is?
So what Bend 3D is with us is we're able to manufacture with additive technology 3D printed tooling. So we run a system where we run a aluminum holder and then we'll manufacture a special form with 3D printing instead of using a conventional steel tool. What this allows us to do is to help a customer go from ordering the tool to receiving the tool within 5 to 10 days and start manufacturing their part. Traditionally, a steel tool is going to be 4 to 8 weeks. So what we're able to do is get the customer up and running. They can get their qualification done. They can get their customer approval done in the lead time shorter than what it takes for a steel tool. At the same time of that production, they can also order, we have our holder system, they can have the additive part be running their machine, making production, getting qualification, and then we can replace this when they're running thousands of parts with a steel insert. So they can go from additive into production with the steel.
Okay.
So that's something newer that we're doing this year.
All right, yeah, so now you've got a year under your belt, and I remember talking to you last year, and there's more of a variety of things that you're doing. Like, for instance, I don't remember wire.
Yeah, so customers are coming to us, can you do this? We'll try it out, test it, and say yes. This 1/4 inch, this is done with 1/4 inch rod. We can do pretty much an all 3D printed tool up to about 3/8 of an inch rod. So we're using steel bearings with polymer inserts. We tested several different applications, and then what material works best doing that application. So we don't have an issue of looking at something and trying something out. So this is a part we did. This is part of a set that's gang to do about a 2-foot bend, all with wire. So they put the piece together, they have their cross pieces wired or welded together, and then they're going to go ahead and bend the wire in there. So virtually no marking, a lot less tonnage because we're using bearings on the inside to alleviate what that roll is over the material. So no material sliding at all through the part, the bearings are taking that load.
Okay. Now, we're working with polymers here.
Yep.
Could someone 3D print metal tools?
We're getting into to metal printing. So we've been printing since about last May, just doing our own internal testing and how does the different printed steels hold up compared to conventional tooling. So we have our own printing that we've done. We've been doing gauges, brackets, tooling inserts with the printing. So we've been doing some different mechanical tools where channel tools or multi-bend forms with the steel and then testing that internally.
Okay,
so currently we're looking at, per the application, whether or not we're going to make that tooling from steel, if we can do it, or is it better to go with the machine tool? So we'll look at polymer, printed steel, or conventional manufacturing and find out what's best application for the customer.
One final question. We're here at FABTECH, and we're surrounded by people that are involved in more conventional type of manufacturing than 3D printing. If you could tell them one thing, what do they need to know about additive that they may not know?
I would say they have to be open to it. We've had a lot of conversations the last couple days of just really simple stuff, looking at some of the gauging and inspection stuff, and they kind of stand back and open their eyes. It's like, oh, you can do that with 3D printing. It doesn't seem like a really heavy, wow application, but it's been kind of an eye-opener to the customers. So I mean, they're amazed with the bending that you can actually do that. We had customers saying you can't bend that with the plastic tool. It's like, well, yeah, here it is.
Yeah. Okay. So what you'd like to tell them is that it can be done with plastic.
It can be done with plastic, yeah.
Okay. All right. Great. Thank you very much.